Let's find the volume of the solid obtained by rotating the region bounded by the graphs of y equals x cubed, the horizontal line y equals to 8, and the y-axis, and taking that region and we're going to rotate it about the y-axis. So let's graph the region first. Now it'll be easier to see what the solid looks like. The graph of y equals x cubed looks like this. And then we bring in the line y equals to 8. It's a horizontal line. And then we have the y-axis. So the region, which will be rotated to generate the solid of revolution, is this region right here. That's the borders of the region. It includes all three of the functions, and then the region itself is right here. To see the solid, we just see what it looks like 180 degrees into the rotation, and then the full 360 degrees. We have a bowl that looks like that. To use the disk method, we are simply going to have to redraw the region and then keep track of just the horizontal slice of the area as it rotates about the y-axis. So here's the region redrawn. This is y equals to 8. This, of course, is the part of y equals to x cubed, and then we have the y-axis. So pick an arbitrary y between 0 and 8. Give it a little bit of thickness. That means we take an interval that contains y that's very, very tiny, and then rotate about the y-axis to generate a disk that looks like that. Let me redraw that disk right over here with all its essential components. So we give it a little bit of thickness. It kind of looks like a pancake, looks like this. And the thickness of the interval that contains y, we call that delta y. It just means very, very small. And then we're going to look at the radius. And the radius of this disk is right over here. It happens to be the x-coordinate of the point corresponding to y on the graph of y equals to x cubed. So first we have to solve for x. X equals to, we take the cube root of both sides, x equals y to the 1/3. So the interval here is x, and the slice of the volume, the piece of the volume corresponding to y, we're going to call it delta v. This means it's approximately the area of its base, which is pi times x squared, times the thickness, which is delta y, and expressing this as a function of y, pi times x equals y to the 1/3, and then we square it times delta y. So this is equal to pi times y to the 2/3 times delta y. And then the actual volume will be the integral. We're taking these slices from 0 to 8, y between 0 and 8. We have a pi out front, so pi times the integral from 0 to 8 of y to the 2/3, and we rewrite delta y as dy. Well, this is a very easy integral. We have pi times the integral of y to the 2/3 is y to the 5/3 divided by 5/3, which we can then rewrite as 3 pi over 5 times y to the 5/3 and evaluate it from 0 to 8. If we plug in 0, we get 0. So plugging in 8, first we take its cube root. The cube root of 8 is 2. Then we take the 2, raise it to the 5th power, that is 32. 32 times 3 is 96, so the answer is 96 pi divided by 5 units cubed is the volume of this solid of revolution.